GeoGebra is extremely effective in studying the idea of fitting a regression curve to a set of points. In this example, I have chosen A through F and plotted them as free points and made a scatter diagram. And then to calculate the regression curve, which is 0.38x plus 1.11, I use the calculation fit line to data. Data is the set of points. And then I also calculated R, the correlation coefficient of the data. R turns out to be 0.81. R can be any number between -1 and +1, and the purpose of this study is to figure out how to interpret R. And some statistical authors use R squared, which is similar to R and can be used to measure what we're trying to discover here. Now watch these three things, regression curve, R, and R squared, as I line the points up. R gets closer and closer to 1. R squared, of course, goes to 1. And the points line up. And if we graph the regression line, we see that the points all lie on the regression curve. Now watch the effect of moving a point or two. Watch the effect to R and R squared. Let's make one point go low. Notice that R squared dropped dramatically. Let's make another point go low. R dropped again, R squared further down. As we lose the collinear points, R gets closer and closer to 0, R squared does also, and the regression curve turns out to be almost horizontal when there's no linear relationship. But now let's line them up. And now what's happened, the line has a negative slope. Correlation is close to -1. R squared is 0.98. The points are very close to lying on the line, but the line goes downward. And then for one final calculation, let's move the points this way. Now we have a pattern, an increasing pattern, but the correlation is only 0.92, and we shouldn't try to use a straight line. So let's use another GeoGebra command, and we will fit exponential to the data. And what I did here was make a set of dots that, instead of being linear, almost follow an exponential curve better. And as a researcher, you have to make that choice. What kind of curve do you want? And do you want it to be exponential or linear or sine or logarithmic or power? There are many choices. Or polynomial in general. But then one final comment, we're done. We want to consider the fact that if R is close to 1 or -1, people say things are highly correlated. What this means only is that the dots almost lie in a straight line. Geometrically, they follow a linear relationship. But to be highly correlated, X and Y, the two variables that are being considered, don't need to be related at all. You can have a high correlation between two totally unrelated variables. But we use correlation and we use linear relationships to try to understand what's going on between two statistical variables. Done.